Lesson 6-2, Draw Inferences from Data. Our statement today says, I can make inferences about a population from a sample data set. Take a look at the solve and discuss it. The students in Miss Miller's class cast their votes in the school-wide vote for which color to paint the cafeteria walls. Based on the data, what might you conclude about how the rest of the school will vote? So look at the votes for the cafeteria color, and remember that these votes just come from Miss Miller's class. See if you can make any assumptions or inferences about how you think the rest of the school might vote if their votes went the same direction as the votes in Miss Miller's class. Out of the 30 votes cast for the new cafeteria color, there were 7 red votes, 12 blue votes, 3 yellow votes, 4 orange votes, and 4 green votes. So what can we say about how we think the rest of the school will vote? Well, if they follow the same pattern as Miss Miller's class, then we would assume or draw an inference that says the school will likely vote for blue. Just like in literature and writing class, we're going to learn about inferences in math. How can inferences be drawn about a population from data gathered from samples? Take a look at example 1. Draw qualitative inferences from data. Sasha is trying to convince her mother to change her bedtime on school nights. She gathers data on the average number of hours of sleep that a random sample of 7th grade students in her school get each night. Will Sasha be able to convince her mother to let her go to bed later? So let's take a look at the data. On school days, Sasha's bedtime is 9 p.m. Her wake-up time is 6:30 a.m. and she gets 9½ hours of sleep. So Sasha, in step 1 right here, displays the data she collected in a dot plot, and she describes the data. So the range is between 10¼ hours of sleep per night and 8 hours of sleep per night, or a range of 2¼ hours. About half of the dots, or half of your data values, are clustered between 9 and 9½ hours. So that's this box right here. What that means is most of the data, clustered means most of it is altogether between 9 and 9½ hours. And 9½ hours has the most dots, which tells us that this is the mode. Step 2. Sasha concludes that about half of the students in her sample get between 9 and 9½ hours of sleep each night, the same number that she gets. You can draw a curve along the dot plot to see the distribution or shape of that data. So we start at the bottom of the data set, which is the 8 hours. We follow those dots to the end, and you can see the shape there. Just like in writing and literature, an inference is a conclusion made by interpreting data or looking at the information you're given and making a conclusion about that information. Sasha infers that about half of the 7th graders in her school get between 9 and 9½ hours of sleep each night. Sasha will probably not be able to convince her mother to let her go to bed later. Now let's take a look at the try it. See if you can look and follow the dot plot given on the right-hand side about hair length to answer and fill in the boxes. In this problem, the data are clustered between 1/2 and 2 inches and between 3½ inches and 4½ inches. So there are actually 2 clusters without much in between them. In this case, Dash can infer from the data that 7th grade boys in his school have both long hair and short hair. Example 2. Draw quantitative inferences from data. Sasha's friend Margot suggests that Sasha calculate the mean and median of the data set to determine whether they support her previous inferences about the population. In this case, we're still talking about hours of sleep per night. Okay, so Sasha's friend Margot wants her to calculate both the mean and the median of the data set to see if they actually do infer what Sasha mentioned back in example 1. The mean of the data is about 9 hours, 16 minutes, and the median is 9 1/4 hours, or 9 hours, 15 minutes. An inference is valid if it is based on a representative sample, and there are enough data to support it. So a valid inference is one that is very likely to be true about a population. Okay, so it has to be a representative sample, and there has to be enough data to support it. So you can't just ask 2 friends or 3 friends, because that's not enough data to support a conclusion. In this case, the mean and median support Sasha's inference that 7th graders get an average of 9 to 9 1/2 hours of sleep each night. Now look at example 3. Compare inferences based on different samples. Margot and Ravi are also trying to get their parents to let them stay up later. They collect data about the number of hours of sleep a random sample of 7th graders get each night. The 2 box plots show their data. Do Margot's and Ravi's data support Sasha's inference about the number of hours of sleep that 7th graders get? In other words, does the data that Margot collected and the data that Ravi collected support Sasha's inference that most 7th graders get between 9 and 9 1/2 hours of sleep each night? When you look at the box plot, you need to remember what those pieces are that create that box plot. In this case, the median time is 9 1/4 hours in each random sample. However, based on the box plots, Margot and Ravi can infer that less than half of the 7th graders get between 9 and 9 1/2 hours of sleep each night. So these data do not support Sasha's inference. Now look at the try it. Alexis surveys 3 different samples of 20 students selected randomly from the population of 492 students in the 7th grade about their choice for class president. In each sample, Elijah receives the fewest votes. Alexis infers that Elijah will not win the election. Is her inference valid? Explain. Well, the first thing that we need to do is we need to take a look and see if this sample meets the requirements of a valid sample. And then we can determine if there is enough information here for a valid inference. First of all, we notice that Alexis surveys 3 different samples of 20 students and that they are selected randomly from the population. Okay, that's the population of 7th grade students for class president. That right there tells us that we have a valid sample. Okay, we have a representative sample, 3 different samples of 20 students, and they are selected randomly. In each of those samples, Elijah receives the fewest votes. Alexis's inference that Elijah will not win the election is a valid inference because it is based on a representative sample, and there are 3 different groups of 20 students. So 3 times 20 means that they surveyed 60 students in the sample of 492 students in the population. So this is a valid inference. Okay, because the sample is a random and representative sample. Now let's consider example 4. Make an estimate from sample data. Derek is writing a report on cell phone usage. He collects data from a random sample of 7th graders in his school and finds that 16 out of 20 7th graders have cell phones. If there are 290 seventh graders in his school, estimate the number of seventh graders who have cell phones. So what we need to do in order to answer this question is we need to draw back on our knowledge about proportions. We are going to write and solve a proportion using the information we have to predict the number of seventh graders who have cell phones. So the information that we are given says that 16 out of 20 seventh graders already have a cell phone. Using that data, we're going to figure out how many seventh graders would that be out of 290. So to solve this proportion, we are going to find C, in other words, the number of seventh graders with cell phones in school. So in order to do that, this is a division equation. We are going to multiply both sides by 290. 16/20 times 290 is 232. And I'm going to go work this out right over here to show you how they got that. Now remember, when you multiply fractions times whole numbers, you're going to do 290 times the 16 and then divide that result by 20. So this gives us 4,640 divided by 20, which is the 232. So about 232 seventh graders in Derek's school have cell phones. Now I want you to complete the try it. See if you can use the new information about eighth graders to determine about how many eighth graders in his school will have cell phones. You should have gotten 279 eighth graders. The proportion that you need to set up to solve this looks like this. 18/20 equals E over 310. So we're looking for what is equivalent to 18 out of 20 if there are 310 eighth graders total. And last but not least, let's take a look at the key concept. You can analyze numerical data from a random sample to draw inferences about a population. Measures of center, like mean and median, and measures of variability, like range, can be used to analyze the data in a sample. Don't forget that the mean is an average, and the median is the number in the middle of the data set. The range can be found by subtracting the high number and the low number to determine how much space there is between those two values.